And all of you know me by now. If you need to get a hold of me, these are the ways to do it. I forgot to mention yesterday, if you do send an email, please be sure and put ISC London or something in the subject. Otherwise, it goes right into the round bin, and I'll never respond to it. So if you do try to get a hold of me on Facebook or Twitter, don't hold your breath. As many of you already know, social to me is down at the pub with a beer in my hand. It's not sitting in front of my computer. So if you want a response, what I'm telling you is email me. Okay? And with me this afternoon is Mr. Todd Carter.
How you guys doing? I'm Todd Carter. I'm a SharePoint master. I also teach the master course, and specifically I teach the performance. So this is a subject that is near and dear to my heart. So very, very important, often overlooked subject. And so we hope to do it justice in 1 hour. We're
going to try. We do have a lot of demo stuff that we're going to try and get to, and I know everybody's more worried about the party than they are about performance testing at this point in the day. So we'll try and get you out of the time. This guy's shaking his head. No, I love it. Good. So we're going to go to 6:45.
But that's real world, right?
All right, here's our agenda. We're going to do some background on some performance fundamentals, some of which is really more in the IT pro realm, but it's things that you need to think about and need to understand. Then we're going to go into some development-specific topics around performance. And then finally, we're going to look at testing and some profiling, and Todd's got some cool tools and things he's going to show you that can help you out in this area. So let's go ahead and start with some performance fundamentals. There's a whole realm of performance with regards to SharePoint and all sorts of knobs and dials and things that you can tweak and turn on and whatnot. Most of it has absolutely nothing to do with the developers. However, what is important is when you give the IT pro a solution and they come back to you and say, this was all working fine until you gave us the code, there's something wrong with your code, you need to be able to have an intelligent discussion to say, no, it's not my code, or to say, all right, have you checked this or have you checked that? Can we really narrow down that this is a code problem? By far, the largest area that causes problems in performance in SharePoint is a database. Would you agree, Todd? 9 times out of 10, it's typically a database problem.
If it's not custom code, it's a database.
It's never custom code, it's a database.
Wasn't scaled properly.
So the first questions we want to ask around performance is, how is the database environment configured? Have the IT pros gone in and done proper maintenance on their database environment, and have they done it for you in your development scenario? You may be trying to optimize something in dev that is absolutely not going to be a problem when it gets into production, but you got an old slow pokey box, because they always give us, right, all the budget we need for good development environments. And so you may be trying to optimize something that in production they've already optimized. So this is part of the conversation. Have they gone in and tweaked the autogrowth settings on the databases? Are they doing database defragmentation? More importantly, have they sized their content databases right per site collection? Although the documentation says you can have up to 4 terabytes in a single content database, there's a very big fat asterisk on that, which comes with a lot of other things along with it, which means if you haven't invested millions of dollars in your platform, don't even try to make this work. You're still looking at a reasonable limit somewhere in the 200 to 400 gigabyte range for a decent content database. Not that it won't perform well, but you'll never be able to do any DR on it if it gets larger than that. If they have SANs involved, for example, because IT pros love big boxes with blinky, shiny lights, as you can tell, because there's one sitting over there that Steve just couldn't help but bring down here. They like to have big refrigerator-sized boxes with lots of disk in them, right? Because they can see all their little blinky lights. They can pull things in and out. It makes them feel good. But if all they did was plug that in, and they didn't go in and assign LUNs to each one of those databases, they didn't separate out the temp DBs from the content DBs, they didn't put logging on one set and your actual data files on the other, if they didn't move search over here, and oh, by the way, speaking of search, if they didn't go in there and align their spindles and do all the stuff they're supposed to do to make those content databases sing, that big pretty box they have is nothing but a big waste of money. They'll never tell you, and if you ask them, they'll say, oh yeah, we did that. So they'll never tell you that's going to be a problem, but it's something that needs to come up in the conversation, or just ask for the documentation, right? Because they write all that stuff down. Making sure that they have regular backup schedules to reduce log file size. By the way, making sure you're doing the same thing in your dev environment so you don't run out of disk space, trying to debug all your solutions. And then, enforcing things like quotas. so these things don't get completely out of control. Talking about list items, the old axiom, just because you can doesn't mean you should, is more true in SharePoint than just about anywhere else. So somebody tell me, what is the maximum number of items you can put in a SharePoint list in 2010? I hear 30 million? Huh? So I'm between 30 millions and billion. Does somebody want to bet $1? Okay.
Is that Carl Sagan? The billion? Millions.
We don't know. There is no hard limit, as far as we know. But at some point, depending on your configuration, it's going to start falling over. Why is that? Well, let's just say that there are opportunities for optimization in the way the underlying data architecture was built. Was that PC enough statement? Every list item in every list, in every site, in a single site collection in one content database is all stored in one table in the database. You heard that right. If you have thousands of sites in your site collection that each has, I don't know, 10 or 100 lists, and each of those have a couple thousand list items, all that goes into one big fat table. So when you do something innocuous like SP list item collection, and you go and get all the items that you're looking for in a specific list, that query that you're executing is executing across potentially millions of rows in that table. That's why we have query throttling built into the product to prevent you from bringing down the system, and SQL will take that anyway and just escalate a table lock on you when you try and do those reads. What I'm saying is your specific problem that you're trying to solve or specific piece of code that you're trying to write could be impacting everybody who's using that entire system and you don't even know it. Should you be using SharePoint to hold millions of items? Well, that's open to debate probably, depending on your particular scenario. But you might want to think about what's happening in other portions of the site or the user base as compared to just the one particular piece that you're trying to deal with. One of the things I hear all the time from the IW side especially is, well, we can just put everything in folders. Okay. So now I get a pretty folder icon. What's that done to help me? Absolutely nothing. Folders help view performance. They don't do anything for the number of lists that are on an item, and it certainly doesn't do any good when you're trying to issue a camel query against all of that content. Makes absolutely no difference. In 2007, we had a real problem with the list view web parts. That's why we had that mythical 2,000 item limit in 2007. It was not a problem with the database. It was a problem with the list view web parts. Fortunately, in 2010, those have gotten better. They're now XSLT based. That doesn't mean they're great because they're XSLT based, right? So now you're getting a whole big bunch of XML that you're having to transform. Better, but not ideal. Still, if you have a whole lot of list items that you're trying to retrieve and parse through and display to the user, write your own web parts. Don't use the out-of-the-box stuff. List definitions. We always talk about what is a large list. How big is a large list? By definition, a large list is 5,000 items because that's the point at which, by default, SQL will escalate a row lock to a table lock. And when you make a query and it returns 5,001 items, you're going to lock for that very brief period of time anybody from being able to do any operations on that particular table. That's what we call bad. So they put a query limit into the product that you can adjust that and dial it down. And by the way, that is configurable in SQL, but caution, Will Robinson, maybe not a good idea to change that. However, you can talk to your IT administrator about saying, okay, give me a window in which I can make these operations, or let me override that when I'm doing it from the object model. You have to talk to them and make a case, right, or get the admin password and go change it yourself. You could do that too. One of the things that really throws people off is row wrapping. So this one can be a real killer for performance in the product. A good one is surveys. So in the SharePoint database, we have fixed table widths. And so that means in the data table, we have 55 text columns, 16 Boolean columns, 8 date time fields, or what have you. So it's a fixed column width. When we create a survey, most of the time we have 20 yes/no questions or multiple choice questions, right? So we're going to exceed that field column width. The way that they get around that is they just wrap the row in the definition, and so now you have two rows for that table definition, and they join them together so you get a nice big wide one. That overcomes the problem. The issue with that is that single row wrapping event can reduce your query performance by as much as 35% right off the bat. So if you're trying to work at those, look at the way those lists are configured, or if you're sitting down to design your data model with your list items, think about, am I going to incur a problem here because I've induced row wrapping by the way that I've designed this particular table? Or just tell them not to use surveys. That'll work too. Remote blob storage. I love this one. IT pros love remote blob storage. Ooh, it's a fancy term, right? We have to buy extra software for it. That's awesome. Remote blob storage moves big binary objects off onto disk. It does absolutely nothing for performance because you still have to go through the SharePoint database to get to that object and then bring it back. It's just the metadata is stored in the database. The blob is somewhere else. Not going to do you a lick of good when you're trying to initiate queries against the database, so don't fall for that line. Remote blob storage is good for reducing the overall size of your SQL database and getting those blobs out of there. Doesn't do anything for query performance. I already mentioned the throttlings and locks. The 5,000 one is the biggie. Think about how you're going to deal with that in your scenario. It is configurable. There's some happy hour time periods. If you look in the web application settings, you can see that there's some configurable options for that. But actually, the best thing you can do to get around the querying throttle limit is ignore it. Use Content Iterator and don't mess with it. There's a specific class. How many people have used Content Iterator, by the way? Right? Okay, so that's limited to the people who actually knew it was there, I think. So there's a method in 2010 you can call. It's a content iterator. You pass it the query that you're going to execute, and you give it an item limit, say 4,999. And it will go out and it will retrieve all the items that match that query set and give them back to you in batches of that size. So it never exceeds the query throttle limit. Then you take all of those when you're done, and you've effectively got your SP list item collection that you can then iterate against, okay? So that just ignores that limit altogether, says I'm just going to get stuff in batch. Because a camel query, when you pass it in, is going to give you back all the records that match that camel query. Use Content Iterator and avoid that problem altogether.
Okay, caching. So you guys have all heard caching. Typically, whenever we talk about, you don't really have to see a performance talk without talking about caching. So caching is a little bit of a variation of, Doc, it hurts when I do this, and the doc says, well, don't do that, right? So caching is exactly that. We're trying to do something once and then use the work that was previously performed to make the next user's experience better. So really, when we talk about caching in SharePoint, there's really three types. We have page caching or page output caching. This is based upon ASP.NET output caching, and I'll show you a demo on that in a little bit. And then we have disk caching. This is known as your blob caching. So we have that's also available to you as well. And then finally, we have object caching. And object caching is really, in many regards, is a black box. It's nothing that you specifically write to. It's something that you're going to get by using crossless queries. Or cross-site queries. Is something that will actually be there for you and used for you as well. One of the things you can look at, though, is from a black box perspective, is the perf counters around there. So there are perf counters for object caching. And typically, when your goal should be about 90% or better for a hit in that regard. So I've seen customers that have a 60%, and the entire farm is just totally sacked. So really, in the 90% range was where we found most customers, if they with proper object caching, sizing, things like that, was kind of the sweet spot for most of those folks. One of the reasons you might not want to use output caching is when you're in cross-site queries. If it's a very specific query that you're doing, you need to really think about whether you're going to turn on that bit that says yes, use object caching, because object caching has this little known issue where if you use caching with cross-site queries, what happens is it goes and grabs a lock every single time there's a cache miss. It grabs this lock. It's a site collection lock, so it's going to grab that lock and then go do the query. Now, if there's another query happening at the same time for a totally different, irrelevant information, what happens is it has caching as well. It's going to try to take that lock. It has to wait on the lock, this global lock, global within a site collection lock, and then block behind it. Now, mind you, he's blocking behind a thread that when he finishes and returns is not going to, there's still going to be a result in a cache miss, right? Because we're going after two different data sets, right? So what is interesting about that is that you can actually get, this becomes a hot lock sometimes, and you'll back up behind it. So it sounds counterintuitive, but for some queries, when you look at your camel queries, look at them and look, are they pretty unique in that regard? In other words, the one I ran into with my customer recently was where they actually used the user's zip code was in there. The U.S. zip code was in there. And so the odds of another user hitting that same server using the same zip code within the expiry timeout, within the expiry of that, was very rare. So it sounded counterintuitive. We actually turned that off. And by turning off caching, we don't, when we see a cache, we don't even try to look at cache because it's not going to be there. So therefore, we don't try to take that lock. So we go directly to the database. So what was happening there was the database was operating just fine. The web front end was operating just fine. But we had a lot of idle. A lot of threads were in flight, and they weren't doing anything. They're backed up behind this lock. What we did was remove that lock on those specific queries. We saw CPU on the web front ends go up. Not too bad, right? Went up a little bit. SQL went up a little bit, but the actual throughput was increased. So we removed that bottleneck. So output caching. So page output caching is typically a publishing page feature that you're going to enable. You enable it the site collections, which I'll show you in a little bit, and you enable this through cache profiles. So cache profiles are a way to really kind of configure the output caching for a specific scenario, specific users, things like that. We have these called very-bys. We have very-by user rights, query strings, headers, custom, and browser, things like that. So what a very-by is, if you think about how we store these things, all we're doing is storing them in the HTTP cache, so the HTTP cache object. And we store them in which is a dictionary of a key value. And all we're doing in this very-by is varying that key that gets built. So this big, massive, long key, it's a string, and that's what we're doing is we're putting these things into the cache based upon those things. So when you want to vary by something, so for example, vary by a query string, that query string then gets added to that key and thereby builds the uniqueness. So in other words, if the query string didn't match the previous request, it's going to result in cache miss. We'll go fetch it, we'll put it into the dictionary, and then with that additional key. So that's kind of the way that works. You can actually set it so that you can actually cache based upon page layouts if you want. You can enable that or disable that if you want. And you typically want to use this in a very high read versus write scenario. Anytime, typically you get very high read and write scenarios. You can actually have a time to live, or you can have it check for changes. So you can configure it either way. So a time to live is a explicit expiry that you put on there. So whether changes happen or not, it doesn't matter. I'm keeping that page changed. And then one other thing to note that you will typically use a little bit more memory, clearly, right, on the machine. Now, the advantage to that, however, is you're going to use additional memory. That's okay because what's going to happen is you're going to do a lot less processing on that box as well. So what's going to happen is when you decide to cache this guy, it's going to be sent out to the client. The ASP.NET's HTTP module is going to catch that. He's going to see he's supposed to cache it, and he's the one that puts it in HTTP cache. The request comes back in for that same page. That same module, ASP.NET module, not a SharePoint module, looks at that request, builds that query string, builds that key, if you will, looks and says, okay, I got a cache hit, and it actually serves the page up. So none of the processing pipeline actually really gets, it gets invoked, but much of it gets cut off, so you don't do a lot of processing there. So you pay a little bit of tax, if you will, in memory, but you more than make up for it in additional items that are getting created in memory and processor and things like that. So object caching. So object caching is used as HTTP cache. It's one of these always-on things, so you can't really turn it off. You can configure it, but it's something that you're always going to use. Typically, you're going to see where you're going to use it for navigation, like I said, cross-site queries, things like that. We say plan for about 500K of RAM per site collection. You definitely need to configure this. It's very important, the super user, super reader. Miriam has a blog post on how to do this. But there's two aspects to the super user, super reader. So what you need to do is you need user accounts for that. You need to make sure you set up your web app policy that points to these guys. In other words, your super user is going to have full control. Your super reader is going to have read-only or viewer, if you will. And then you go in and set this through STS-ADM. So it's super important. The good thing about it is, though, their error messages are really clear on what's going on. So it doesn't take a genius, really, to go through, see it in the event logs, and go, oh, great, I've got to configure this, because he tells you it's not configured. So that's pretty easy to get around. Again, as I mentioned before, the performance counters, you want to use that to see how this thing's working for you. So is it or is it not working? So again, we want a really high cache hit ratio. It means it's working. A low cache hit ratio typically means you probably have some very distinct or unique queries happening, and you want to try to reduce those. But you will not get, ideally, you will not get to 100%, but again, you should try to achieve much more than 60%, and hopefully, if you can, in the 90% range. Blob cache, things that you need to know about blob cache are they are there to help the content database. So asking the content database to do less work is the idea here. It doesn't mean I can serve up images faster, but what it does mean is I can actually take those images, get them out of the database, and get them on disk. Right? And serving them from disk is going to be hopefully beneficial to the content database because it has to do less work, right? And typically, we can actually, in some cases, serve those pages up faster. Now, images up faster. Now, what that means is we're not going to be going back and checking to see if the item's been updated and things like that. That means the item in the content database. Now, what you need to make sure you do is put it on disk. That's cool, but make sure you put it on a disk that A, has enough space, and it's not really one of these really slow disks, right? So typically, we recommend not putting it on the system disk if you can. There is a background thread that runs every 5 seconds, I believe, and what it's going to do, it's going to process the change control, the change log in the content database. It's going to iterate through there, run through there, and expire the cache. At the time that it does that, it's expiring the cache, but it's not fetching what's in the database and writing it back down to cache, right? So it's going through and expiring. So if you have 5 web front ends, on average, right, every 1 second, one of them is going to be going through and iterating through this thing, right? But going and iterating through those change logs is still better than going and hitting that database constantly. A couple things about that. So the files that we're going to serve and we're going to put on disk are going to only come from document libraries. So if it's not in a document library, it's not interesting to blob cache. So that means if it's on disk somewhere, you put it in your images folders or something like that. If it's on disk, don't worry about it. It'll be served from disk. If it's in document library, yes, we will take care of that. One thing to note, though, if it's in a web folder, so that's the absolute worst place you could store images is in a web folder. What's a web folder? Open up SharePoint Designer, go down to the All Items, I believe, is the last item in the, or last menu item in the navigation, and select that, go in and create new folder, then put an image in there. A couple things about that. First of all, it won't be put in blob cache, and it won't get any headers added to it at all. So no cache expiry headers at all. So it's the absolute worst place you can do. That means then every time this user hits the page or refreshes, they're going to go get that image every single time from the database. Blob cache, however, will put an expiry header on there so that it will ask, we will do an if modified, the browsers will typically do an if modified, and then we'll be able to answer that correctly and say, yeah, it hadn't been modified, and keep what you have. So we actually get that benefit too. So blob caching, again, has a couple benefits. One, we reduce the load, hopefully, on the content database. And two, we can actually allow the user to keep those images for a longer period of time. So the cool thing about output caching is when it works. It's not so cool when it doesn't work. You want to flip these? I got it. So this demo, I name it, Don't Be Like My Customer. So, their pain is your gain, right? So what we want to do is we want to go ahead and enable page output caching. Not object, but output. And very hard. If you guys are consultants, you get right there, you can build 2 hours, right? And make sure that's checked. If it's not, there you go, you can build another hour there. So this enable debug cache information. So this is really cool, right? What it's going to do is in the page itself, it's going to give you a couple things. If it's not caching, it'll tell you why. That's cool. If it is caching, it'll tell you it'll give you timestamp, so you can kind of see when the page was last generated. So that's kind of nice. So what I've done here is I actually have this. Let me zoom in. I have ISC. So this is my internal authenticated web application. I've extended that, and so I have actually I'll flip over here to Firefox, and I have the, up here, I have the public-facing version of this as well over here in Firefox. So what I will do is you can go over here and you can refresh this. Now I've turned page output caching. Now if you guys had noticed before I refreshed this, that's unfortunate, that was about 152 milliseconds was what's the response time. Look at the response time now, 315 milliseconds, right? So it's going to bounce around a bit. Let's keep refreshing this guy, see what we get. 303 milliseconds, 66 milliseconds. So what that tells me when I see that is typically that massive variation of 10-fold, 20-fold, it means page output caching is probably not working. So let's take a look. Do a view page source. We'll scroll to the bottom. And this is a very bad list. Let's see if you guys can see that here. So page output caching is not working because there's more than 10,000 uniquely secured objects in the site. Now, here's the thing. When you deployed this, this might not have been an issue. However, it can become an issue over time. So one of the things you probably want to monitor, and it's really up to you on how you want to monitor that, is the fact that this will just happen and nobody knows. Nobody will be notified. You won't get an email. You won't get a health alert. And it won't, unless you have verbose logging turned on for the publishing cache, it's never going to show up anywhere. What will show up is just a little bit worse performance on your entire site, right? So probably not the way you want to find things, because probably that'll happen right before you're supposed to go to a really cool party. So what we want to do is we want to go ahead and get rid of these guys. So one of the things you can do is get the ID, the GUID, if you will, of your site ID, and you can do a query a SQL, as soon as you select the right SQL content database. There we go. Now, what this query does is perm site is going to return you every object that has what we call unique permissions, or has permission sets on it explicitly. And one of the things you can do when you go and look at this guy is you can see here, I've got this knack for naming things. So the large list here, you can see that I've got the list ID, the large list. So he's telling you exactly where these items are. So it's, by using this, you can kind of get a sense of where these items are in your site collection, because this is 10,000 across the entire site collection. So if it's a massive site collection, keep in mind, if you've got a lot of permissions out there, it's going to potentially cause you issues. So if you're running this guy, and you're pretty close, you're running pretty hot, you're at the 9,800 range, keep in mind, you're really, any time now you could flip over and hit the 10,000. 10,000 is not configurable, 10,000 is hard-coded, so don't try to follow bug and say it should be 11,000, because that won't work. So you can see here the majority of them here. So what I'm going to do is I've got this really cool utility to fix that. It's called ISC. So it's going to delete that list for me.
They're really secure now, aren't they?
Well, that's how you fix stuff, right?
Business is happy.
Yeah, business is happy. They don't know. They never were looking at that stuff anyway. So here we go now. Now, one thing I did want to point out was earlier, before I did this demo, I created a list called GUIDs. Again, I know I have a great name and knack for naming things. Put a couple things in there, I deleted it, and then I deleted the list. Now, those items, they still show up, but I don't have a list GUID, right? So what it is they're actually in the recycle bin. So keep in mind that if you're going to do this, you probably want to do this through the API instead of trying to go through and clean it up with the UI, because you're just moving your problem. Now your problem's in the recycle bin. So things in the recycle bin count, okay? Another thing I wanted to show you was the code that I wrote, not that it's some genius code, right, that I wrote to actually cause this issue. And the point I wanted to make here really was I'm creating a permissions. So I'm creating an SP role assignment here, and I'm going through, adding these items. Where we go here? Let's see here. Here we go, right down here. Adding these items, I'm breaking role inheritance, and then I'm going ahead and assigning the role. Now, what's interesting about that is every one of those items has the exact same permissions, right? The same role assignment, the same collection. When they say unique permissions, they mean unique items with permissions, not unique permissions as in ACLs being unique, right? Because if that were the case, then all of these would count as one because they all have the same permissions, but they're all uniquely permissioned. So keep that in mind when you're looking at the problem here and trying to solve the problem. This will not solve the problem clearly, right? So we need to make sure that we understand that. So I've fixed my problem, right? So, and notice, guys, I'm doing this because I don't have the really cool Metro look, right? I'm doing this on my own machine, right? Because this is pretty hacky code, so nobody wants to run that on those nice, pretty servers next door. You know what the difference between hack and a feature, right? Documentation. There you go.
That's because somebody failed to write the documentation.
Well, step one, you've admitted you have a problem. Okay, look, so 34 seconds, 40 milliseconds, it's still not getting me there, right? I'm still having a problem. So let's take a look at We know we have that output cache thing, right? But that's a real pain to have to go in, view source, and navigate to the bottom. So what I did was I wrote this little guy here. Now, let's do IS reset. Now, if you're a developer, you got this button right here on your box. Boom! Right, that's kind of a nice feature right there. That's in the Todd SDK there, right there. Just push that and you get the IS reset going on. So that guy's restarting, and I'll go ahead and warm him up with this guy. And then let me show you what this is doing. And so all this is doing is using, let's zoom in real quick. All I'm doing here is using tinyget. I'm doing a GET request to the server and passing in my URI. And then effectively I'm giving it a user agent string so he thinks I'm a real browser and responds to me. And then I'm just doing a dash data, so I'm piping out the entire response. And then I'm just piping that to a find, and then I'm looking for the actual comment. So clearly if you have a lot of comments in your page, this probably won't work. But for me, it's out of the box, so it's the only comment in the page. So the idea here is rather than opening that thing up constantly, you'd use this, and potentially you use this as a monitoring mechanism as well. So let's see if this guy's warmed up at this point. No. Boy, okay.
It would have worked already on those big boxes next door.
I'm sorry, did you say something? I feel a little bit like Penn and Teller here. Right? You're so tall and stuff. All right. All right, so here we go. So yeah, that's 1 minute and 11 seconds. Yeah, I think we can improve upon that, right? So I can imagine people would complain there. So 148 milliseconds. So let's take this guy, take a look. All right, so pure anonymous, so I've cached it, right? You can see the time that I cached at 10:47:18, 10:47:27, 10:47:29. So when you see something like this, the good news is SharePoint believes he's cached it. The bad news is this time keeps changing. That's bad, right? Because that means it's not really caching. So what's going on there? Well, the problem here is potentially a couple things. If you installed MS11-100, there is a bug that, or unfortunate feature, as we like to call them, that actually got injected with that, and that's an ASP.NET fix. It's a security fix. It got pushed down, and unfortunately, it's kind of the bugs kind of in a little bit of a quagmire between the two groups, right? SharePoint saying it's ASP.NET, ASP.NET saying SharePoint, things like that. Now, what happens is effectively what's happening is, and I will show you a little bit here what's going on. So this guy's not caching. Here's the bad thing. Is that going to show up in the ULS log? Nope, because SharePoint thinks it's good. SharePoint thinks it's cool. So here's the issue that I injected here, and again, another reason why we don't put this on those boxes next door, because any little thing happened over there and they just blame us for their demos not working. So effectively all I'm doing here is I'm just adding a cookie to the response, right? I'm going through here and generating a cookie and adding it to the response. Actually, you can't even see that because I didn't scroll down enough. There we go. What happens when that MS11-100 is installed? He does this. He causes causes SharePoint's SP module to do the same thing. Anytime there's a cookie in the response, the ASP.NET will not cache that response. So SharePoint thinks it's all good. It's cached. It's met all of his criteria to be cached. Comes down to ASP.NET. His module looks at it and says, nope, that cookies collection's got at least one cookie in it. I'm done. So he won't cache it. And that's effectively what happens here. So I don't have that fixed. So what I did was I wrote my own module to do that. So to fix this, you can see I added a very simple way. So I don't have to uninstall this guy. Now when I go in here, it's 10:49:45.
Still not working. But that was a cool no cookie file.
No cookie, why? No cookie, TXT.
Should you use the?
That's right. There's a translation
Should you use the
issue.
red button from
There's
the
a
Todd
translation.
SDK?
Take a look. Well, that's going to fix everything.
That's what they say.
Yes. It's like this.
So the moral of that story is don't install that hotfix. Oh, wait, it's in Windows Update. Oh.
Yeah, that's a bummer, isn't it? So on my blog, I have an anti-MS11-100 that basically it's a module that all it does is look to see if SharePoint added the cookie and check to make sure it's not the same value that's already there, and then just go ahead and remove it. And effectively, your caching starts working again. So let's take a look and see if we can figure out what might have happened here. Oh, there's my issue. I've got another cookie in there. So let's fix that guy. Yeah, you know, all these cookies and stuff. Yeah, you guys getting all punchy right before the thing here, right? So let's see here. Let's go here. Let's go to this guy. Let's open with. So what?
Now you're going to do an IS reset.
This video's so getting edited. Telling Steve I got to record this again at my house because he's freaking heckling.
It always works there.
Yeah, yeah. Well, no, just because I don't have people heckling me at home. Yeah. I have kids. The door. I have a door. Okay. Let's see here. Let's refresh this guy again. 5 milliseconds, 4 milliseconds. Awesome. So this guy, 1052, 1052, 1052. So that's what we want to see. So, you know, perfect world, right? Only in a dev class do you get claps for something that should have worked. Yeah. It works out of the box, but for some reason, a dev course, if you get it working, it works great. So effectively what happens is you got to make sure that, so you should see these things in sub 10-second, 20-second range, right? So, you know, again, just monitor for that. Make sure there's no cookies. So use Fiddler. Make sure there's no cookies in the response, and go forth and.
We good?
Yeah, we're good. We're done.
Okay, so now we're going to talk a little bit about data access options and things you should be doing when you're developing solutions for SharePoint to make sure that you're producing performant code. Huh? Do you need a microphone? Do you want to participate, AC? Are you feeling left out? You haven't talked enough this week, have you? All right.
Do you want my shirt?
Every crap. Okay, so data access options. There's lots of ways for you to get data out of SharePoint, right? And these are just some of the available options. You can go to the server object model or the client object model. You can do camel or link. You can use a portal site-nav provider. We haven't talked about that this week, but that's a cached object that you can use to access data. The legacy web services still exist in 2010. You can still get at those. The same ASMX web services from 2007 are still there and available to you. You can also use search, as Matt showed us, and you can use the new rasto data stuff to get data out. But the question is, when you're looking at all the ways to get data, what is the most performant? If I'm going to go access 10,000 items out of a list, what's the fastest way that I'm going to get them? And the answer is search. Beyond any shadow of a doubt, search is the fastest way to get data out of SharePoint. It comes at a cost because it's not immediately relevant. It's only as good as the last crawl that you ran. It doesn't have context, et cetera, et cetera, et cetera. However, if raw speed is what you're after, search is the way to go. As you go down the other options, the speed starts to fall off, right? Most of the times we'll end up just making a sacrifice and saying camel link is the best that we're going to get for this particular application. It gives us the most. It gives us context-relevant data. When I say context, a search result only comes back with the managed properties that were indexed, right? You don't have a SP item that you can then get a bunch of properties from, right? You just have a bunch of strings that are available to you to manipulate. Camel and Link do give you all of that. You have an SP item that you can manipulate, but they are slower by orders of magnitude. As you work down the list, REST isn't bad, but it has a context problem because you can only do one set of list results at a time, et cetera. And then by far the slowest is the client object model because there's a lot of proxy stuff that happens with that and returned as a JSON object and all the processing that happens. So in terms of pure performance, when you're architecting your solution, if there's a way you can build your large data queries on search, by all means you should. If you can't, fall back to doing camo and link. If you're remote, try and do REST if at all possible. If that's not good enough for you, you can drop back to the legacy web services and then client OM at the end of the day. Remember that what's going on the IT Pro side is going to impact how good your queries are. So make sure those SQL indexes are being maintained. If you have lists that have a lot of items and you know you're going to be querying on one specific custom field, make sure that field is indexed in that list so that your queries perform faster. We've already mentioned using the content iterator. Be aware of camel joins. Camel joins, not only is there a limit, you can only do 8 camel joins, 8 joins, 6? So somewhere around there. There's a handful of joins that you can do in a single camel query, and they absolutely murder performance. So keep those to a minimum if at all possible. In 2010, Microsoft gave us a nice little tool that we can use to help us troubleshoot performance problems as we're working. It's called the Developer Dashboard. You can crank this on in your environment, and it'll show you down at the bottom a list of all the stuff that's executing on your page. And there it is. This is what it looks like. So this will show up down at the bottom of your page. It will show you events that are happening inside your code base and along with some other stuff. Now, there's some things that you need to bear in mind about using the Developer Dashboard. For one thing, you're only going to see things on the left-hand side that have been instrumented to be shown. If you just crank out a web part and add it to the page and fire up Developer Dashboard, you'll never see anything. You have to use SP monitored scope in order to make it work. Wrapping your calls in SP monitored scope means you can trace down your events and methods, and you can also make them hierarchical. So you can start with a scope on top, and then you can walk down your methods, and it'll show you up the chain how they perform relative to each other as you build in those monitoring scopes in your code. But you've got to instrument it or you'll never see it. Also, there are page lifecycle issues with the Developer Dashboard. The big one that comes up is delegate controls. When a delegate control gets injected onto the page, which is something that happens after the parent control has already been instantiated in the control tree, you'll never see it in Developer Dashboard, even if you instrument it. It won't show up. It's a lifecycle issue, and it won't happen. So be aware of that if you're looking and trying to troubleshoot those particular things. Turning on the Developer Dashboard in your environment is very easy. You go out and download Wiktor's WSP, add it into your solution, and crank it on from central administration. If they won't let you touch those boxes, they're evil administrators. Shame on them. You can fire up PowerShell, and there's some quick code that you can turn the Dev Dashboard on and off. Shameless plugs. Nothing but shameless plugs out of this group. Okay. Yeah, there's also a way to do it in CKS Dev. Okay. Yes, what? Did you read that line?
Yeah, so I said,
Does not work with sandbox solutions.
since you don't have that, what do you do?
So don't ask me silly questions like that. So this doesn't work in the sandbox. I told you I was going to trip over that stinking third speaker up there.
The third speaker back here.
All you can do is write it out. You can put it in the trace logs, right? You can put it in a logging list like we showed the other day, but there's no way to really instrument that from the sandbox because it won't ever show up. Okay, what we're going to do real quick is I'm going to do a load and performance test for our actual solution. Now, 9 times out of 10, typically, devs aren't involved with doing load and performance tests of a solution. Typically, they test it. They come up with some really arbitrary parameters that don't mean anything, and then they come back to you and tell you it's all your fault, right? And then you have to try and fix it. However, it doesn't hurt to establish your own baselines, and I like to do this a lot when I'm deving projects before I turn it over to the customer. Send them the code base along with my test baseline. That way, if it's bad in their environment, it's their own bloody problem, not mine. Right? So I like to code up quick tests so I can baseline the performance of my application in my dev scenario. So what I've coded for you here is just a quick web test. that's going to go out and it's going to hit the home page that has our article summary on it, and then it's going to follow it through to a link to the first article. So we're actually exercising in a web test that our code is functional. It has to run our code to go out and generate the summary, generate the articles, then you've got to click on it, it has to go through to the details page. So we're exercising the code elements that are happening on the back end. A couple of things about this solution. You're going to see something unique here, and that is we've added this little thing here called SharePoint Test Extenders. This is something that Todd put together to help us check something called the SharePoint Health Score. For every page that's being rendered in SharePoint, behind the scenes for the health and analysis, it's calculating a score. And there's an algorithm that it uses to determine what is the relative health score of a page, and it's a value from 0 to 10. And it'll show you a health score. If you want to see this working, fire up Fiddler, load up any page in SharePoint, and come down here and look at the bottom, and you'll see this right here, the X SharePoint health score. Lower numbers are better. So to find out how any SharePoint site is performing, everybody in here with public SharePoint websites just went, oh! You can just go down and look at the bottom of the headers and say, hey, it's good or bad, right? So what we added to the code to the web test was this little bit of code that'll go in and check that. It'll grab the header and check that health score and compare it against a value that we've defined in our data. Right, so it's just grabbing and seeing if the health score is greater than 0 and making a comparison, and that'll come back as one of the validators in our test. So here's our test here, and we have a health score rule for each of those pages, right? So this is telling us whether SharePoint thinks that page is performing well or not. It's additional validation in our test. We can then go ahead and run these tests, and when we execute the test, it'll load up, start cranking out the test. This is just a web test now, and see if this actually works and kick it back and go green or red or whatever what happens when the web test runs. So this validates that it's performing, that SharePoint thinks that it's working well, and so forth. So I'm gonna kill. Oh, there it goes. So you can see it running and passing on both of those tests. Now. That's all well and good, but that's just a web test. I can validate the same thing by opening up the browser and looking at it. The real question is, what happens to this code when we load it up? One of the things that we never did to test all their big, nice, pretty infrastructure over there is slam it with some load tests to see how it was really performing. They're going to do that tomorrow morning, actually. But what I have is the code solution running on another server called SP Test in our environment, and this, my Visual Studio stuff where my tests are being executed, is on SP Dev. So we actually are using their infrastructure to call across and run a test. So we've got a load test here that we have created that will go in and run. Thank you. There's our load test. So this is going to take the web test that we've created, and it's going to run it with a mix of agents. I think I've only got, how many did I put in there? 25 agents or so. So we're not really going to slam it, but we are going to have multiple agents running, hitting this thing, and see what our test results look like when it runs. So I'm going to go ahead and crank that up and get it going. This is a fairly basic test. You can get crazy. There's a whole wizard where you can insert things like think times, which you really shouldn't use when you're doing load tests. Yeah. And what's wrong here? Database could not be open yet. We don't care about that. Carry on. Yeah. Why did it stop? Because it couldn't open the database?
Yeah. Are you on, what box are you on?
I'm on Dev.
Is there SQL Express?
No.
Yeah, that's a problem. You got to point to another database.
No, but it should run even without having the database. It should set up and run and load my counters. No. Oh, you little rat. Right. There's no reason this shouldn't be running.
Hit the run button 3 more times.
Right. Yeah, I'm just gonna keep hitting it until this bloody thing works.
It works in the elevator, doesn't it?
Yeah.
The elevator.
Well,
it's like, oh, he's in a hurry.
Much for that
I'll go faster.
Anyway, what I was going to show you with that is it brings up the graphs to show you each of the pages get separate lines in the graph, and you can look at the page load times and all that sort of stuff in the graphs. Those are the reports that you can generate, right, that validate the solution that you've coded. Say, I've created this load mix test with these sort of things. I've validated that the code performs under these parameters. Now, you, Mr. IT Pro, can go and create all your tests, but you better come back to me with some factual data data that says my code is really the problem because these are my test scenarios. Just going and delivering them the code and saying, hey, it worked great on my box, that doesn't give us any metrics, right? That's like being out all night and coming home. Your wife says, where were you? And you go, I was at a friend's house. If you don't have pictures showing you were at your friend's house, right, you weren't there, buddy. All right? So take some good solid metrics with you when you do that code turnover so that you can validate your code. All right. I am staying on the same machine.
There you go. Oh.
Probably going to switch back to me in a minute. There we go. See?
Yeah.
I told you I was going to do that. Come on. There we go.
It's not performing very well.
All right. So I'm going to skip through this stuff real quick. This is just some background material on performance testing, right? Another slide saying why you should do it. You could take this stuff to your boss and say, give me some time so I can do some of these types of tests. Now we're going to flip over and talk a little bit more about some of the things that you can do in the development environment to actually performance profile and manage your code performance for your custom solutions.
Yeah, so Visual Studio 2010 has built in a profiler. You can actually there's a separate download you can actually do as well. So what happens is when you do this profiling, a couple things is typically if you go live and go into production without doing some of this test and understand where your bottlenecks are, you're going to have to, unfortunately, you're going to have to pay either way, right? You either do the testing up front or you're going to have to do it later. So you end up having to do a lot of troubleshooting. So a couple tools to use for troubleshooting is Visual Studio 2010, and then I wrote a tool called Snap, which is a little debugger that I wrote that I'll show you in a little bit and effectively can do sort of the same things. Visual Studio will create a VSP files. VSP files, when it does this collection, actually writes this VSP file, it can potentially get very large and stuff. The modes that actually will run in, the one that's most interesting to you is sampling. And so what that means is sampling is effectively a statistical. It's going in and just every once in a while and taking a snapshot of what's going on and effectively trying to tell you from that what is going on inside your process. You can actually use a standalone profiler to collect the data. And then, of course, you have to use a full version of Visual Studio. Therefore, the ultimate version of Visual Studio actually analyze the data. So the way sampling works, one thing I did want to point out is a standalone profiler is really cool. It actually works, Visual Studio 2010 version of this works on even virtual machines. The 2008 version does not. It only works on physical. So make sure that you get the right version. The downside, however, is that most production environments that are running SharePoint do not have .NET 4 framework. This guy requires a .NET 4.0 framework. So figure the odds that you're going to go into an environment having performance issues, and you go, oh, by the way, I want to put this tool on to get some data, and oh, you have to install the .NET 4.0 framework, right? So as we say in Texas, that dog won't hunt. In other words, they're not going to let you do that, right? So effectively what happens then is hopefully their physical hardware, then you can put the 2008 on and get around it that way because 2008 requires the .NET 3.5. So the way this works is in every processor, modern processor, there are these internal performance counters. They're not our normal performance counters that we look at. They're performance counters inside of the CPU. What happens is Visual Studio, every 10 million cycles, wakes up and gets called back and said, hey, this CPU has hit its 10 million cycle count. Here you go. And effectively what he does is he goes and grabs a stack. He grabs a stack of what's on the CPU at that time. So if you have 8 CPUs, it means every 10 million cycles on each one of those, it'll wake up and he'll take a snap of only that stack that's on the processor at that time. So this is really good for catching things that are CPU bound. So things that are doing a lot of processing of CPU, these things will typically, right, always bubble up and be on the stack, be on the stack at every 10 million cycles, right? So the way they do this is they use 2 different counters. One is an exclusive count and one is an inclusive count. So every time they wake up and they were to snap this call stack, they're going to go ahead and add the inclusive sample. They're going to increment that by 1 for each one of these frames. This is a stack and each one of these are frames. The guy at the very top is not only going to get an exclusive sample of +1, he's also going to exclusive sample of +1. So when you look at this, you can say, look, things with the very high exclusive samples, right, are always at the top of the stack. It means they're doing a lot of work, right? Is that a problem? It depends. The guys that have a very high potentially inclusive sample are causing a lot of work to be done, right? So it depends upon your perception, right? So here we have a lot of chiefs, and then we have the one little Indian, right? You know, almost like your job, right? So, so this is kind of what it
Or
is.
like
So,
this dev team.
yeah, so, yes. So it really depends upon your perception of where you are in the stack is if you're a problem or not, right? So, you know, so basically that's how it works. So you need to pivot and look at it from those two perspectives. So profiling with Visual Studio really goes through these 4 things: installation, configuration, execution, analysis. Again, standalone version, I did put this out here. That's unfortunate. We'll change the color and stuff before we get this out to you guys. But that's where it's installed to. The reason I call that out, is because you can't, trust me, it gets installed. Right? The reason I call that out is because there's no UI, there's no icons, there's no nothing after you get done, right? So it is done, and you're like, oh, great, where'd it go? And that's effectively where it went. I've already explained this one to you, and I've already explained this one to you, so we'll keep going. So let's do profiling with Visual Studio, and then I'll show you profiling with my tool, and the Snap, I'll show you the difference between the two. One difference being a $5,000 price difference. But so
We don't care about that.
Mine's free today only.
We have MSDN, right? We don't care about that.
Yeah. There you go. Yeah. Okay. So what I did was to do profiling inside of Visual Studio.
Red button.
Dude, what a red button.
I know, it's a hardware problem.
There's really a couple things you need to do. So the Visual Studio Profiler is a CLR profiler. So this, unfortunately, in 3.5, the only time we actually inject that profiler is it's a DLL effectively. It's a COM object that we're actually referencing. The only time we do that is the beginning when the CLR starts up for the very first time. That means IS reset. And that also means my demo is going to be really slow. So I went ahead and did that right before while you were doing your work. So I kind of warmed it up. Effectively, what I did was I ran this little script here that will actually, all I'm doing is setting the path to my tools and then doing IS reset. And effectively, actually, what I'm doing is I'm running. Oh, yeah, I didn't type it out. Let's do this. You call this VS Perf CLR ENV global sample on. What that's doing is it's making the proper settings in the environment variables so that we can start the process. So when the process starts up, CLR looks there, says, okay, great, I'm going to load that guy up. Once you do an IS reset, you can then go in and use a tool such as Process Explorer, and you want to verify that that DLL is actually loaded up into the process and stuff. So it means then you need to make a request, start W3WP. That guy's loaded, you're golden, right? He's not profiling, and he will be loaded in every single CLR process that starts from that point forward. No biggie, though, because he's not profiling yet. He's just loaded and sitting there and doing nothing, right? Well, there was a joke there, but I didn't want to touch that one. But, and then the next thing you do is you do connect. And so it's VS Perf CMD, and what you're doing is you're telling him, look, this is how I want you to sample. This is how I want you to start, and effectively we're going to use sampling, right? There's memory and some other things you could use. We're going to do output. The output to our VSP file. Make sure that's a local. Don't try to do UNC or FTP or something crazy. Then we're going to tell it the user that's running the app pool account. In my particular case, it's the farm account. And then you use this thing called cross-session. What cross-session means is you can go in from session 0 to session 1 and things like that. Always use cross-session. It doesn't hurt if it's not there, whatever. Effectively, what I'm doing is when this guy starts up, he's starting up a name pipe. And what he's saying is anybody can connect to this name pipe, but I'm going to kick them out if they're not that user. So it's setting up a little bit of security, right? So it's all in the same box. So that's what's happening. So we run that. The next thing you need to do is you need to run this command. Let's just scroll down because I kind of did all this already. We need to find out the process ID that we want to profile, right? The guy that's running this. So my Snap tool actually will generate a list of managed processes. So I go down here, and this is the ISC app pool. So I can see it's 1860. So I want to run this guy. So I just do. Okay, he's attached, he's running. I'm now profiling. My VSP file's been created, and I'm going to town. Now, here's the thing. The scenario we're trying to show you here is a customer has reported this page is slow rendering, right? It's coming back pretty quick for me, no big deal, right? But they say it's slow when there's a lot of users on it, right? So we can look at developer dashboard. That wasn't a public version. We can look at the developer dashboard and see 124 milliseconds is not slow, right? But they're claiming it is when there's a lot of load on the thing. Well, unfortunately, developer dashboard doesn't really work when you're there and there's not a lot of load going, right? So you got two choices. You can either do something different or you can just close it, no repro, which is a favorite of mine, right? So what I like to do is just do a little bit of work here, right? So what I'll do is I'll do this. Let's see, do Control K. Effectively, what I'm doing is I'm opening up a bunch of tabs to that same URL. Right? This is the poor man's load tester. So what I will do is I will do a refresh all. Woo! You laugh, but I went to a customer and did this. So here we go. So we're profiling. We're clearly seeing. Some of these are obviously, you can see they're taking longer than 124 milliseconds, right? So there we've gotten that. So let's verify. So we've got our VSP guy going here. He's creating this, so we're good. So let's do this. Let's do number 4. What he's doing is he's calling VSPerf CMD shutdown, and basically he's calling global off. He's backing everything out. So we stop profiling at this point. We're done. Now at this point, you got this VSP file created. It's 2 meg, not too bad. Now you're going to think, oh, I'll just double click on that. That's embarrassing. You don't want to do that in front of a customer. So what you want to do is you want to go Visual Studio, and you're going to go and do this guy here. This is really cool because I go, oh, I didn't know you could drag drop. Yeah, you drag drop. So now you guys are going, well, what else do you need besides this? Typically, what you want to do is you want to get the VSP, and you want to also get any custom DLLs and stuff. So I know we don't like to say that, and we'll keep this kind of a closed session. Odds are it's probably your code. Right? I'm sorry to say that. There's configuration, there's code, there's database wasn't scaled properly and stuff. But honestly, sometimes if it's down to one page that's running slow, it's probably something specific to that page, right? That's probably the best bet. So keep that in mind. Be objective about your troubleshooting here, but don't rule out your code, right? So even my own code, it's kind of difficult. You go, well, you know what? Let's assume it is my code or something like that. But definitely don't rule anything out. But this guy will help us determine that. Now, when you open this guy up, he's going to give you a couple things. He's going to give this cool little chart. He's going to show you the CPU, right? So you can see my CPU is not really, it jumped to 40% at the very end, right? That's not CPU bound by any means. So this tool, I can't really trust what this tool is telling me because he's best used in a CPU bound scenario. So if that thing was in the 60, 70, 80% range, then we might want to take a look at this and really consider what he's telling us. But this guy, a little shaky. So what I'm going to do is, they have this thing called hot path that he's going to give you automatically. Hot path is telling me that these are potential 2 issues with your code. Now, what you want to do is typically if you have your code available or if you have your DLLs available, you don't need symbols, just the DLLs themselves. If you put them in your symbol path when you open this guy up, he'll automatically resolve these for you. If you see a bunch of like hacky little names and things look broken, it's because he's looking in your symbol path and he's not finding the DLLs that guy references to. So 2 ways. Use the public symbols that Microsoft offers. So, http://msdl.microsoft.com/download/symbols. And also, I'm sorry? Got it? All right. It's easier than some of the URLs I've seen you guys putting up here.
What's the bit.ly for that?
They're there on the slides, yes, sir. However, by default, they're configured inside of Visual Studio. If you would take 5 minutes to take a look. So you could do one or the other. All right. So what this guy's telling me is these guys are my probability of being my problem. Now, here's the thing. You don't want your problem to be in something you can't fix, right? Because that's very difficult. So you can see here I've got this. He's telling me it's my ISC, task web part, task web part, task web part, user control, background worker. This is what he's telling me my problem is. The great thing, and the thing that makes this work, this demo work great, is because I have the source code on my box. And my DLLs were built debug, and because they were built in debug, it tells you the source path. Awesome. I can go and click on this guy. He takes me right to my code. That's the problem. Now, what he's really pointing to is this guy right here. Well, it's because my symbols aren't matching up. Let's go to declaration. Let's see what the problem is. All right. Do you guys see the problem? Because Visual Studio says this is your problem. Yeah, I don't either, right? So I don't know how to fix that. So Visual Studio is kind of nice at getting us pretty close, but it's not going to give us the exact answer in this particular case because our CPU is not there. If our CPU would have been there, this guy would have probably been a good candidate to take a look at. So what I did was I wrote another tool. Actually, one thing, look at this. So this guy's saying you're spending most of your time, in fact, let's go back here. He's spending most of your time in this. I'll use this little fire icon. Fire! There we go. So he's saying here's your problem, right? And this is kind of what I've kind of already showed you. Now, you can see here I'm calling toList, and these are the bad things, right? Now, what you don't want is you don't want your problem to be like in this Lambda thing, right? That's not good. You can't do anything about that. But here's the things you can own. So look at the things that you own in your stack that you can potentially influence, right? Now, this guy's saying my problem is here in this background worker proc. Unfortunately, you can see here, and the reason he's doing that is because of the inclusive samples and exclusive samples. You can see those are relatively high. You can see the percentages and things like that. So there's different views you can look at. So that's where he's kind of pointing to and going down that direction. Now, the problem is, and what he's not telling you, if you look at this, he gives you those nice kind of cool samples, right, that tells you, let's go back. Go to the top here. My little mouse thing's not working here. There we go. He tells you how many inclusive samples and things, but notice what's not here. There's no timing information here. You know it's spending time here, but you don't know how much time is being spent here. So again, this guy is, he's trying to tell you where that's on the stack the most and stuff, but that might not be your issue because there's no timing here. There's timing in Developer Dashboard, but there's no timing here. So be sure that you don't just go hang somebody up because of that. So what I want to do is I want to show you this other tool that I wrote called Snap. And it's available to you guys. I will share it to you on the last thing. So Snap is simple because that's how I roll, right? So what we want to do with Snap is I want to get a list of, let me do this. We'll get a list of processes. The one I want to use, we're going to do this guy again, right? We're going to do our load test. All right, while it's warming up. So what he does is he actually wakes up and does a stack. He goes and grabs every managed stack and dumps them out into an XML file. So every time he takes a snap, right, he'll actually create a new file for you, right? And so and then it goes creates file after file after file, right? And so what you're going to do is let's run this and get a list of the processes. The guy I care about is this. Where's ISC? They're 1860 still. I didn't do an IS reset, but that's okay. Now, he takes a number of parameters, PI for process ID, PN for process name, or AP for app pool. So if you have an app pool and you can't remember what process or anything like that, don't care about, just put the app pool name in there. He'll do the same thing. So I'm going to run this guy, and actually, let's go like this. So you can't find the
P-P.
P. Oh, sorry. We'll get rid of this. These are all common. Okay. So what it's going to do is every few seconds, it's going to take a snap and stuff every 10 seconds. And so what it's going to do is it's going to tell you that the file that it snapped the file. It's going to tell you the process ID, the memory that's being used at the time that took the snap, and then how long it actually paused the process to actually gather that information. And then, of course, it does it multi-threaded, so it releases the process right away and then writes it to a background thread. So while that's running, we've got these snap logs being created. So here are the files being created as he's taking a snap. So let's do our little stress test. Oh, that is sexy. I could do more tabs, but I don't want to show off. Tab envy, right? All right, cool. All right, let's stop this bad boy. Actually, he hasn't. Actually, you know what? He's snapping every 30 seconds. Let's not do that. Let's snap every 10 seconds or 5. I'm making this up on the fly. Look at that. It's agility. All right. Now, I've run this in production and stuff, and it's not a big deal. It's a single EXE, so there's no install. So it's again, it's a safe thing. It's not going to damage any of your code. Let's see. Okay, so we've done a few things here. It's snapped a few times. Let's go look at this. Now, the first thing you're going to say is, geez, where's that little parser that's going to dump out my XML for me and make it nice and pretty? Don't have one. That's a...
Is that on the to-do list?
You know it. Yeah. So here are my logs that I snapped and stuff. Now, what I typically do is, let's go ahead and move this over. You only really need to look at one, I've found. Now, I just said that in a recording, so we'll have to do a little bit of editing if that's not the case. But what I do is I look at the one that's the largest file, right? He's the most interesting. He's got the most data to look at, right? So this one, I've sorted by size, and that guy is 40K, right? This particular case, size matters, so we'll take a look at this guy. Now, here's what I do. You look at these guys, and you're going to recognize some stacks, and you're not going to recognize others. So let's just take a look here. See this read SNI, for example? That's reading SQL. So he's hitting SQL. He's waiting on SQL to return something. Look at this. This is an SP object cache. Not interesting. See these little threads, stacks like this, this performance counter agent. Again, he's just going and updating performance counters. Not the droids we're after, fellas. So let's keep scrolling down here. Okay, this guy, publishing, cache object factory. No, not interesting. Some more object cache stuff, some more performance counter stuff. It's taxonomy, so that's a taxonomy refresh in the background. All right, here's one. Looks interesting. Our stack is called he's calling populate tasks. Okay, so he's the top of the stack. We won't have to go down through, look, page load, populate tasks. Okay, who cares? Scroll down. Here's another one, populate tasks. Here's another one reading from SQL. Populate task in background. Okay, that's that one that Visual Studio said was a problem. Here's another populate task. So that's third or fourth one we've seen. There's maybe the fifth one we've seen. So 5 threads out of, if you go back up and look here, out
17.
of 17. So about 30% of your threads are doing this thing. If you see it above 20%, that's the thing you're after. If you've got more threads in flight, they're all doing the same thing, that's probably your issue. Okay, I've seen this many times. And you go, well, this is a demo, it's a contrived example and stuff. No, literally, it's that easy. I've done it many times in many customer environments, same thing. I've done it when they had the only profile server was off on the farm's down, right? And every request coming in is trying to connect to the profile server. It times out after 20 seconds. Well, guess what? They're trying to grab a lock, initialization lock. The guy grabs it for 20 seconds, holds on to it, times out, releases it. The next guy goes, okay, I'll have it. And he takes 20 seconds. It's taking the entire farm down. I ran this. You see the stacks. There was 100 stacks that had all those guys waiting on that lock. And you can see it says initialize profile servers. I asked the guys, where's your server? He goes, oh, it happens to be down right now. Bring it up. Brought it up. Problem went away. So actually, we didn't bring it up. We actually started the service on another server, actually, is what we did. So that guy's saying the problem is a little bit different part in our code. Let's go back over here. So he's saying this populate tasks. And I'm a fan of that. Reason being, every guy is going through here, taking this lock, and then calling populate task in background that spins up another thread that's actually doing the processing. So I have a hot lock, right? So all of us are waiting on, they're all serializing behind that lock. So that's the issue. So Visual Studio pointed one way, got us close. This guy actually pointed us to the right direction and stuff. It works, again, with, if we're calling a web service, I've used this on a server down where the customer they're calling an external web service, and on one server it was cool, on the other server it wasn't. What happened was the proxy setting on one server was wrong, so he couldn't get out to the internet, and there were 60 threads waiting on it, trying to get a stock quote. So effectively, it was showing that was the issue. We went and looked at the configuration. It was pretty simple to find out. So, yes, sir.
You were saying the difference between that you built your stuff in debug mode and common symbols and everything. You just need the DLL. Like, does it matter if it's release or debug to get some of the detail? I mean, I know
Good question. So yeah, you just need the DLL because as long as it's not obfuscated, right? You just need the DLL, even in release mode. Because he won't tell you the line number. You won't be able to click and go right to the line number, but you will get you'll get the trace. Absolutely, absolutely. Yeah, and you saw that, right? That's all I have for the other, system.web and stuff. I got those, and they're the same thing. But if you want that ability to go click and open up, that's you need to have debug build, and of course have access to your source. So because I was running on the same box, that my path happened to be the same, that my debug, we embed the path. That's kind of how that worked.
All right, fantastic. That's it, folks. Thanks for sticking around a few extra minutes with us on that one. I know everybody wants to get to the party, so we will. I think most of us will be there tonight. So, of course, if you have questions, if you bring us beer, we'll answer them. If you don't, you're out of luck.
You're better off asking earlier in the evening than later.
Depends on the quality of answer you want. Thank you very much. We appreciate it.
Thanks, guys.